Hello everybody, this is Gary Mrozinski and this is Chapter 7 Part B. This is Chapter 7 of The Microeconomy Today by Schiller and Gebhardt, published by McGraw-Hill. We're talking about the production function. This is the chapter on the costs of production. And we begin by talking about the production function. The production function, remember, is a function that predicts the total amount of output a work unit can produce, a department or maybe a whole company can produce when the number of workers is increased or varied. If you increase by one more worker, then the total output per day should increase. The amount that it increases, remember, is the marginal product of that worker. You hire one more worker, total output increases by some amount. The amount that it increases by is the marginal product of that worker. Marginal product will diminish, it will decrease the more workers you hire. Again, that means this is the law of diminishing returns. As output increases, you can only increase output by hiring one more worker. When you do that, output goes up, but by smaller amounts with each worker you hire. Eventually, it's going to go negative. So when you're looking at that curve on the graph, you can see it's going uphill. That means it's an increasing function. As you hire more workers, output increases, but it increases by smaller amounts. This is a function that increases at a decreasing rate. The rate at which it decreases, the rate at which it increases is the marginal product. The table down below, this is an example of a company that produces jeans, a factory that produces jeans, and across the bottom there, in the graph, across the x-axis, you can see that's the number of workers they're going to use. And then on the y-axis, that's Q. Normally we have Q on the x-axis. Well, we're putting it on the y-axis now. That's the total output of this factory per day. So the table of data that's been graphed, you can see number of workers. That's the first row. And then total output is pairs of jeans per day produced in this factory. And then marginal product is added. That's the bottom row. So the marginal product of the first worker, when you go from 0 workers to 1 workers, total output goes from 0 to 15 jeans per day. All right. Then maybe you have that one worker for 30 days or something, and then the next day you decide, the 31st day, to hire the second worker. Total output will increase to 34 jeans per day. So how many jeans were added per day when the second worker was hired? What's the marginal product of that second worker? 19, right? The difference between 15 and 34. And maybe you have 2 workers for some number of days. And then you're thinking about hiring the third worker. All right, you hire the third worker. Now the total output goes from 34 jeans per day to 44 jeans per day. The marginal product of the third worker is 10 jeans. And so marginal product goes down as you hire more workers. And you remember the reason for that, right? The law of diminishing returns. The more workers you hire, the lower the average output per worker is, right? And the reason for that is because now since your capital is fixed, your fixed plant is fixed, there's more workers being jammed into a facility of fixed size and equipment of fixed size. Major equipment is not increasing either. That's part of your fixed plant. So they're sharing equipment, and output increases, but by smaller amounts. The more variable resources you put into your fixed plant. And this is explaining that a little bit further. Capital is fixed. As labor increases, the output increases, but at a slower rate. The rate at which it's increasing is the marginal product. Output maxes out at point H. So when you go from 7 workers to 8 workers, output actually goes down. The marginal product of the 8th worker is a negative number. I should have pointed that out in the previous table, but you can go back and look if you want. The marginal product of the 8th worker is negative. That means you're worse off after you hired the 8th worker. Now it's really gotten to be a problem. And in fact, you might not want to hire the 7th worker, because look at point G and point H. That probably does not definitely does not justify hiring the seventh worker. The seventh worker costs you something. Now, we haven't gotten into costs yet, but we're going to do that soon. This is the same graph, but now you can see marginal product is graphed below it. So the marginal product of the first worker is 15 bushels per day. And then when you hire the second worker, it goes up to, I don't remember the exact number, maybe 19 bushels per day. And then it goes down after that point. So you actually have increasing returns when you go from 1 to 2, but then it goes down after that. And you might say, well, why don't we produce with 2 workers? That looks like the best point. It's not. You would never be profitable. You would actually be producing at a loss if you used only 2 workers. The output that you're producing is not enough to pay for the capital, and we're going to learn that later, probably in the next chapter. I'll point that out to you, that you might want to think, only having this information, that you should produce at a point where returns are increasing. Well, that's such a small level of output that you're not going to be profitable. All right, so you're going to be producing somewhere where marginal product is diminishing. That's not a bad thing. It's just something you have to understand. Once again, the law of diminishing returns: the marginal physical product of a variable input, labor, declines as more of it is employed with a given quantity of other fixed inputs to your fixed plant. The added output begins to decrease and ultimately goes negative as more and more workers are added with no increase in capital. Remember, this is in the short run. So let's go back to our Farmer Jack example. Remember, the whole point of going through this is to relate this to costs. We're trying to understand the costs of production. That's the title of this chapter, the costs of production. We want to understand what's happening to our costs as we increase output in the short run, given that we have fixed capital, a fixed plant. All right, so Farmer Jack pays $1,000 per month for the land, regardless of how much wheat he grows. So that's his fixed cost, $1,000 per month. That's the cost of his fixed resources. The market wage for a farm worker, we're being told, is $2,000 per month. All right, so now we know what it costs to hire one more worker per month. Your total cost will go up by $2,000, right? That's important to know. That's going to be part of our decision-making process. So here's some more detail. So if you have no workers, let's say you shut down for 1 month, maybe it's the off season and you can't produce. You cannot produce. Well, your fixed cost you must pay even if you're producing 0 units of output. And so the cost of the land is $1,000. That's your fixed cost. Total cost is $1,000. So let's say you hire the first worker and you're going to start producing now. All right. So you're producing 1,000 bushels now per month. What's the cost? Well, the cost of the land, $1,000. The cost of the labor is $2,000 because you're paying that worker $2,000 per month. So your total costs are $3,000 per month if you have a workforce of 1. When you hire the second worker, now you're producing $1,800. We're going to apply a dollar value to that output shortly. Now we're just thinking about the dollar value of the costs. All right, so to produce $1,800 per month, that means you must have 2 workers. Still $1,000 for your fixed costs, plus now $4,000 per month, $2,000 per worker. So your total cost is $5,000. And you can see we're adjusting that total cost for 3, 4, and 5 workers. So now think about what's the total cost to produce 1,000, what's the total cost to produce 1,800, what's the total cost to produce 2,400. These could be points on a graph. We could graph now total cost and see what it looks like as we vary Q. See, we want to get to the point where we're not graphing L anymore. We want to graph Q because our supply and demand curves are graphed against Q. We want our cost curves to be graphed against Q as well. And that's what we're going to do on the next slide. So we're going to focus in on the Q column and the total cost column. So there are the Q column and the total cost column. if we're to graph those, look at what's happening. The more you produce, the more total cost is, and that makes sense, right? So again, if the curve is going upwards from left to right, if it's going uphill, that means it's an increasing function. Total cost increases as Q increases. That is what we expect. But it increases at an increasing rate. See how it's bending upwards? The total product curve, remember that when that's sort of leveled off and plateaued? That's increasing at a decreasing rate. This is the function that increases at an increasing rate. So total cost increases at an increasing rate the more you produce per month. This is Q is in terms of monthly output. Total cost increases at an increasing rate the more you produce. The reason is, I'm going to ask you questions for the rest of this chapter. There's a very good chance the answer to the question is because of the law of diminishing returns. So here's the first time I'm going to ask you a question where you can answer that way. So why does total cost increase at an increasing rate the more you produce? Because of the law of diminishing returns. Because the only way to increase output, to go from left to right on this graph, to increase Q, is by hiring more workers. As you hire more workers, then the output increases, but by smaller amounts. But the workers cost the same as you go from 0 to 1 to 2 to 3, right? But the output is not increasing linearly. All right? The output is increasing by smaller amounts. This is a little deceiving. I should point this out too. Normally when we're graphing a table of data, we're increasing by even amounts. Q is not increasing by even amounts in this table. We go from 0 to 1,000, from 1,000 to 1,800, 1,800 to 2,400. So if you're looking just at this table of data, it's not obvious to you what the shape of the curve will look like. You can't tell that it increases at an increasing rate until you actually graph it. Normally when we're graphing a table of data that has Q in it, we're increasing Q by even amounts. We go from 0 to 1 to 2, or maybe 0 to 100 to 200 to 300. In this case, because of the way we arrived at this data from our example, Q is increasing by uneven amounts, so it's not obvious to you when you look at this table of data what the shape of the curve will be. But total cost will increase by an increasing rate the more you produce. So what is marginal cost? It's the increase in total cost when you produce one more unit of output. So again, now we're not looking anymore at increasing by a number of workers. We're increasing by a number of units per month or per day in the jeans example. So the marginal cost, if you want to increase output by one more per day, maybe you're producing 10 per day. You're thinking about maybe tomorrow you're going to start producing 11 per day. All right, well that means your costs are going to go up, right? Because you have to use more labor hours to produce 11 per day, maybe even hire another worker. Well, the amount that your total cost increase by when you go from 10 per day to 11 per day is the marginal cost of that 11th unit of output. So the change in total cost goes in the numerator, and delta Q, my example, I increased Q by 1 from 10 to 11. So 1 would be in the denominator. But maybe you're producing 10,000 units per day, and you want to start producing 10,100 units per day tomorrow. Well, total costs are going to increase by some. Well, then you would have 100 in the denominator because you're increasing output by 100 per day. Our simple examples, we're going to be increasing Q by 1 at a time. So we'll always have 1 in the denominator. So these first two columns you've seen before. Q, numbers of units you're producing per month. This is bushels of wheat per month. And then the second column is total cost. So you can see how total cost increases as you increase output. Marginal product, remember, is the change in total cost when you increase output by some amount. All right? And it's the change in total cost in the numerator, the change in quantity in the denominator. So when you go from 1,000 bushels of wheat per month to 1,800 bushels of wheat per month, total cost goes up by 2,000, quantity goes up by 800. So 2,000 divided by 800 equals, marginal cost is $2.50 when you increase from 1,000 to 1,800. So the marginal cost of those 100 bushels per month you're adding is $2.50 each. Excuse me. And so that's what's happening here. So now marginal cost when you go from 1,800 to 2,400 bushels per month, again, total cost increases by 2,000. That goes in the numerator. In the denominator, it's the increase in Q. Q only went up by 600 now. So 2,000 divided by 600 is $3.33. That's the marginal cost of those 600 bushels per month you've added. And so look at what happens to marginal cost as we go. It looks like it's going up and up and up, right? Marginal cost increases the more you produce. That's what we expect. Once again, we are in the short run. That's why we have law of diminishing returns to deal with. Your fixed costs are the costs that don't vary with changes in output. So these are anything that you have to pay, even if you're not producing anything. This is something that we thought about a good deal during the pandemic when we had to shut down businesses in our economy. So restaurants closed. Think of any business that had to stop operating. And maybe it's a restaurant that could not serve, and a restaurant, maybe they own their space. Well, they've got mortgage payments probably, right? They've got to pay those even though they're not producing anything. More likely they're leasing their space from some building owner. You've got to pay your rent even if you're not producing anything. The rental payments are fixed costs. How about the insurance you're paying on your facility? Whether you own it or don't own it, if you don't own it, you're still going to insure all of your equipment that's inside the facility because that belongs to you. Anything else you might lose inside that's insurance payments are fixed costs. A portion of depreciation on equipment and buildings. I mean, you could go as far as you want with this, but anything you have to pay, even if you produce zero, are your fixed costs. Your variable costs, those are costs that vary with level of output. Again, labor, but also materials. You're using more materials, consumable materials, materials that become part of the finished product if you're producing a tangible good. Fuel, utilities. You use more electricity. If you double your output 1 month to the next, you're going to use twice as much energy probably, or some increase anyway. Transportation services, don't forget this. You've got to pay to have your finished product transported to whoever you're selling it to, or maybe you're going to pay to transport materials into your facility. And again, labor. We're going to hone in on labor as the variable resource that we're most concerned with, and that's always the case in an economics course. Think about how variable costs change the more you produce. Variable costs are the cost of your variable resources. Just think about workers to make this simple. As production begins, which means you go from 0 units of output per day to small amounts of output, and maybe with just 1 worker or 2 workers, variable costs increase by a decreasing amount, the variable costs of the units you're producing per day. That's because you have increasing returns in the very beginning, possibly. So again, the carpentry shop example where you have 8 pieces of equipment, if you only have 4 workers and then you increase to 8 workers, they might actually become more productive on average. That's increasing returns in the very beginning as you increase to whatever that level of output is. But then beyond that, you're going to have workers waiting to use machines. If you go to 12 workers or 16 workers, now they're waiting to use the equipment, and it's getting more crowded in your carpentry shop. Returns are diminishing. Now when you hire more workers, output still increases, but by smaller amounts. In the beginning, you might have increasing returns, so variable costs will increase by decreasing amounts, but beyond some level of output, usually early on, variable costs rise by increasing amounts. The variable cost of producing more units of output. Remember, you're relating cost per unit now, not cost per worker. But just know that as Q is increasing, you must be hiring more workers, right? Using more labor. You have to. There's no other way to do it. The labor becomes less productive per unit is what this means. And the labor costs the same no matter how much they're producing. See what I mean? So for that reason, to increase Q. As you increase Q, variable costs go up per unit. That's cost per unit goes up because returns are diminishing. Marginal product is diminishing. We're trying to come up with the shapes of these cost curves, and the variable cost curve is really crucial to the whole thing. So total cost is the cost to produce some number of units of output, and that includes the fixed costs and the variable costs. We're going to be, you'll see one time what the total cost curves look like. We're going to be looking at average cost curves because those are the cost curves that are most useful to us in doing our analysis, our marginal analysis. Where we're going with all of this is we're trying to figure out how much should a firm produce to maximize profits. And so in this chapter, we're only looking at costs. You need to know about costs and revenues, right? Well, we're only looking at costs in this chapter, and we're trying to understand what these average cost curves look like because those are the ones we're going to add to the supply and demand curves to try to understand profit. So average cost is just when you take total cost and divide by Q. So fixed cost, remember, is the total cost of your fixed plant per month if it's monthly. Average fixed cost is where you divide by that by Q. How much are you producing per month? That's the average fixed cost per unit. Same thing with average variable cost. You just take total variable cost and divide by Q. That's going to be a U-shaped curve, which I'll explain. And an average total cost curve is when you take total cost and divide by Q. Marginal cost kind of like is an average cost already. So that's going to fit nicely on our graph where we're graphing the average costs. We're going to add marginal cost to that as well. And that's going to be a real important curve. All right, so to remind you, marginal cost is the amount that total cost increases when you increase output by some amount. Once again, a simple example, you're producing 10 per day. You're thinking about producing 11 per day. Maybe you're going to start that tomorrow. All right, well, that means my total costs are going to increase by some amount when I go from 10 per day to 11 per day because I'm using more workers or more labor hours. The amount that total cost increases per day is the marginal cost of that extra unit you're producing per day. The marginal cost of the 11th unit per day that you're producing is the amount that total cost increased by. That's marginal cost. All right, so what does this look like as a graph? At first, marginal cost might go down. That's when you're experiencing increased returns, but then returns diminish. So it's going to reach a minimum and then rise abruptly. It's going to increase at an increasing rate. Marginal cost increases at an increasing rate. Why does this happen? Remember I told you I was going to keep asking you questions that have the same answer. Why is it that marginal cost increases at an increasing rate beyond some point? Because of the law of diminishing returns. They increase the more you produce because the only way to produce more is to add more workers to your fixed plant, and the workers' average productivity is going down. So that means to produce more, the costs are going up faster. So here's a slide that just shows you simple equations and just to get you used to where these come from. All right, so total cost equals total fixed cost plus total variable cost. Now, we don't usually show the T's for fixed cost and variable cost. So when you see in a problem or an example fixed cost, that means total fixed cost. When you see variable cost, VC, that means total variable cost. I'm not going to be writing the TFC and TVC. I'm just going to be showing you FC and VC. Just know that those are total costs. All right? So then average fixed cost is just when you take total fixed cost and divide by Q. Average variable cost is when you take total variable cost and divide by Q. And same thing for average total cost. And again, these are the ones we're going to graph. So we have to understand how these quantities change the more you produce. And we already talked about marginal cost. Again, as you go from left to right on one of these graphs, Q is increasing. That the amount by which total cost increases as you increase Q is the marginal cost. All right, here I would like for you to complete this table. Fill in the holes in this table. And I'll talk you through some of this, and then you can pause this video as you figure out the rest of these, and then I'll show you the solutions. All right, so my first question to you is, can you figure out what fixed costs are in this example? Fixed costs are the costs that do not change as you increase Q. This is the cost of your facility, the land, if you're leasing the land, the equipment, everything, insurance. So what are your fixed costs? Here's what you're going to get used to doing in any of these problems. Go to the row in this table where you're producing 0 units of output. That's the very first row, right? Q equals 0. Looks like we still have costs, $50. All of those costs must be fixed costs. It's got to be, right? If you're producing 0 and you still have costs, those are fixed costs. So if you had a column here for fixed costs, which you don't, you can add one off to the left if you wanted to, then it would be 50, 50, 50, 50, 50, 50, 50, 50, right? No matter how much you produce, as you go from row 1 to 2 to 3 to, you're increasing Q by 1 each time, right? Maybe this is like units produced per day. It's 50 no matter what. Well, we can figure that out because we went to the row where Q is equal to 0, and we see that total cost is 50, then fixed cost must be 50 in this problem. All right, so then what about variable costs? If you're producing Q equal to 0. 0, right? There's no variable cost because you don't have any workers to pay. All right, let's go to the second row. All right, if you're producing 1 per day, that's the second row. Now they're telling us variable costs are $10. What is total cost? We could figure that out because we know what fixed costs are. Total cost equals variable cost plus fixed cost. We just said that fixed costs are $50 for every row of this table. So then total cost must be $60. How about average fixed cost? That's when you take fixed cost and divide by Q. So if Q is 1, we're in the second row of this table now, average fixed cost is just $50 divided by 1. So that would be 50, right? Average variable cost is filled out for us, and average total cost is too. How about marginal cost? All you need to do is look at the changes in the total cost column as you go from 0 to 1, 1 to 2, 2 to 3, 3 to 4. So when you go from 0 to 1, total cost went from 50 to 60, so the marginal cost of the first unit of output is 10, and that's already filled in for us. All right, let's do the second row, and then I'll leave the rest to you. All right, so if we're producing 2 per day, they're telling us variable cost is 30, total cost is 80. What is average fixed cost? Well, fixed cost is 50. 50 divided by 2 is 25. Average fixed cost is 25. How about average variable cost? Average variable cost is, in this case, 30 divided by 2, 15. How about average total cost? Average total cost is 80 divided by 2, or 40. All right? Now, how much did total cost increase by when we went from Q equal to 1 to Q equal to 2? It went from 60 to 80, 20. So marginal cost of the second unit of output is 20. That's the far right column. All right, and again, I'll let you pause here and fill out the rest of the table. So here are the solutions. Again, the very first thing you do when you see one of these tables is you try to figure out what fixed cost is. Go right to Q equal to 0, that first row, and if you're given total cost, you know that all of that must be fixed costs. Fixed costs in this problem are $50, and then you go from there. You're given enough information to fill out the rest of the table. That's it for Part B of Chapter 7. In Part C, the last part for Chapter 7, we're going to return to our jeans manufacturing firm example, and we're going to start by looking at how the shape of the marginal product curve, the one on the left, results in the shape of the marginal cost curve, because from this point forward, we're going to not be looking any longer at marginal product or total product. We're going to be looking at only the cost curves. But we're going to remember that it's the production function, the shape of the production function, specifically marginal product, as you increase Q, that determines the shape of these cost curves. So I'll see you in Chapter 7, Part C.